Greetings everyone. Today we're going to discuss the fourth question of Codeforces round 888 div 3. So you can pause the screen and read the question. Okay, let's just read the question. Your friend have an array of n elements, calculated its array of prefix sum and passed it to you, accidentally losing one element during the transfer. Your task is to find out if the given array matches a permutation or not. It's given here what is permutation. And what is prefix sum, right? So basically what it's given that, let's say we have an array of five element, let's say A, B, C, D and E, right? And accordingly there will be prefix sums also, right? And let's say it's given that one of the prefix sum is being deleted, let's say the C is being deleted. So we have to find out like whether there exists a permutation such that the prefix sum array is valid one, like it just matches to our array. So indirectly our main task is to find is like whether this arrangement of prefix sum is valid or not, right? So cool. So what are the possible ways of deleting the prefix sum? One way is to delete the prefix sum element from starting, another way is to delete the prefix sum element from the end, and another way is to delete somewhere from the middle, right? Let's say that D is being deleted. So and one thing we know that the sum of all elements, like from 1 to n, is always nn plus 1 by 2, right? Let me write somewhere, like nn plus 1 by 2. Cool. Cool. So it is always nn plus 1 by 2. So this thing is, and one thing also I would like to mention that if the sum of all the elements in from 1 to n in nn plus 1 by 2, then each digit in prefix sum array must be smaller than nn plus 1 by 2, right? And the prefix sum array must be strictly increasing in nature because it's the prefix sum, and prefix sum should always increase. So it should be always strictly increasing in nature, and each digit should be less than nn plus each number should be less than nn plus 1 by 2. So these are the two constants which you can apply directly on the input array. And if it fails, then no matter what the configuration is, the answer will not be possible. And let's say these constants are satisfied by these input prefix sum vector. So what next? That just I have mentioned that we can delete from start, end or middle, right? So if I delete the element from the end, so which element will be missing? I guess this one, because sum of all the elements in the from 1 to n will be nn plus 1 by 2, and if nn plus 1 by 2 is missing, it means what? The last one is missing, the last prefix sum is missing. So yeah, so for last one we have just find the way, right? And let's just now remaining two cases only, like deleting from the start and deleting from the middle. Cool. Let's just see one thing that, okay, let's just see one thing, right? Let's say I have here my A, my B, my C, and my D, and E also. Let's say here, okay. And let's say if I have deleted the C, so and we know the C1 is deleted. So what are the possible numbers? Like if we subtract B from A, it will tell what? That in our nums array or the original array from 1 to n, which number was at this position, 0th one, which number will be at first position, right? So B minus A. And this number is missing, right? So now if we subtract D from B, D minus D, then this will be surely greater than n, right? Because obviously because the difference, if one number is missing and it's prefix sum, so if we make the difference of not adjacent but of these types of neighbors, then it will surely greater than n. You can take example and verify that. And again, if we subtract these to 1, then we will get another element of our array. So right, and it will tell what which element is present, the element in indexing 3. So what I want to show here is that if the element is deleted from the middle, then we will get 2 elements out of how many elements? Out of 5 digits, we get the 2 digits, right? So basically the 3 digits is also in our hand. And if I am telling that I have deleted the element from the middle one, then my first digit of my in original permutation should be equal to A, right? This is the fact, right? Because obviously, so my first digit should be equal to A if I am deleting my number from the middle somewhere. So now I have 3 elements, right? This one, and one is A. So whatever the 2 digits are missing, right? Whatever the 2 digits is missing, because out of 5 I have I got the 3, so basically the 2 digits will be missing. So whatever the 2 digits are missing, these 2 digits, surely if we add these 2 digits in the B, then it should give D, right? Obviously, no, because whatever the, you can do some try run and you can verify that. But if we add 2 digits which are not being yet used out of 1 to n, right, to B, it will give C, because there is a number missing from C, and if the C is present here, then the C minus B will give a number, D minus C will give a number, and if we add to those 2 numbers, then it will what? D plus that number is equal to D, right? It's a simple mathematics. Okay, so that thing for sure. So we know what will the condition if we say the number is deleted from middle. Now let's see what will the condition if we say the number is deleted from starting. So I am telling that my starting element is being deleted. So if I say that my starting element is being deleted, it means what? It means that D minus C will produce a valid number from my permutation, right? And when I say valid number, it means the number is between 1 to n, and that number is not being used somewhere. Let's say here it comes 2, and again here it's come 2, then it's not a valid number. 2 is not here a valid number, because 2 is already being used, and in permutation n number will come only once, right? So from here we will get a number, let's say it is A1, and from here we will get another number, let's say it's A2, and from here we will also get a number which is A3, right? So out of 5 number we already got the 3 numbers, right? Out of 5 numbers we already got the 3 numbers. So how many digits remain? 2 digits remain, and if 2 digits remain, then for sure the sum of these 2 digits should be equal to what? Equal to B. And if you ask why, then the A is missing, right? And my first number is missing. Sorry for interruption. So yeah, so as I was telling that if my first number is missing, then if we add these 2 digits from original permutation, then it will be surely equal to B. Why it is equal to B? Let's say these 2 numbers are A0 and A1, right? Then let's say it's A0 and A1, then either the first number will be A0, and if we add in A0 another number A1, let's say my first number is A0, right? And if I add A1 into it, then it will surely give me B. So that's why I am telling that the 2 digits which are remaining out of n, because out of 5 we have already generated the 3 digits, right? And the 2 digits which are remaining, its sum should be surely equal to this B, right? Because if you construct the permutation of 5, then sum of first 2 digits will obviously equal to B. You can try this by using a sample test case of, let's say, generating the digit, right? So yeah, this was the whole approach of this question. Let me just walk you through the code, and then we do dry run. So yeah, I have also written here that as I have just mentioned, the 3 positions are where from we can delete the number. And what is valid number? The number which should be between 1 and n, and number should not be consumed, because it's a permutation and the frequency of every number will be always 1 in my nums vector, or basically the original permutation array. So what I have just said, that if we delete the number from the n, then n plus 1 by 2 will be missing, and then we will just insert the n plus 1 by 2 in my prefix vector, and then just construct the original array, right? And if the original array which we have constructed is a valid one, then the answer will be yes, as the answer will be no. Then there are another two possibility remain. One is from deleting the element from the start, and another is way to delete the element from the middle somewhere, right? And if we delete from the start, it means what? That out of n elements, my n minus 2 elements will be out of n elements of my permutation, n minus 2 elements I have already generated, right? So only 2 elements are remaining, right? And just I have shown that if we add these 2 elements, that should be equal to the first element of the permutation, or first element of the prefix. Sorry, if we add the remaining 2 elements, that should be equal to first element of the prefix array, which is provided in the question, right? And if this condition is obeyed, then the answer is 1, else the answer is 0, basically true or false. And the last condition is like what? The element which we have deleted is from the middle somewhere. So if it is from the middle somewhere, then we know what the total number of numbers which we are constructed, or which we have already got out of n element from our original permutation will be n minus 3, right? And just I have shown that if we have deleted somewhere from the middle, then my first element is the same element which will be in my the original permutation array, right? So indirectly we have got the n minus 2 elements. So the remaining sum, right, what is the remaining sum? Remaining sum is like out of nn plus 1 by 2, right? Out of nn plus 1 by 2, if we subtract all the digits of permutation which we got till now, so whatever the sum is remaining, that is called the remaining sum of remaining, right? And if we subtract the prefix of 0 from it, it should be equal to the temp of 0. And what is temp? The temp is the, I will show this in the code, okay? And let's just see directly the code. I have taken this input, right? And I have created a maxi and the flag here, right? So it's just taking input and checking that my current digit, it should be greater than my maxi, right? And if this condition is contradicted, or if this condition gets false, then it will turn the flag into 1, because the array, my prefix should be strictly increasing, and there should be no duplication in my prefix array, and it should be always increasing one, right? And in this way I have calculated the maximum number for my prefix sum vector, right? This prefix sum vector. And if any element is greater than nn plus 1 by 2, then it means what? That it is not a valid prefix sum vector, so answer will be obviously 0, right? So that thing is done here, and just I printed the no and continue. Now I have just created the unordered map, and why I am using the unordered map? To store the frequency, or to check whether the digit of from 1 to n is already occurred or not, right? Because as I just mentioned, it is a permutation, and the frequency of each element from the 1 to n should be exactly once, so like that. So the first condition I am checking that whether the element is missing from end or not. Let's say, yeah, I have just written that the last element is missing or not. If the last element is missing, then the last element of my permutation, the last element of the permutation array which is provided to me, should not have the nn plus 1 by 2, or basically I can say the last element should not contain the sum of all the elements, right? And if this is the condition, then I am telling that the last element is missing, like in this case, that it is the invalid one, I know, but let's just write the valid one only. What's the valid one here? 1. Let's say it's 1, 6, 8, and 12. So just like in this case, the nn plus 1 by 2 is missing. So we know for sure is that my last element is missing. So if my last element is missing, then the one of the digits of that permutation will be v of 0, right? Because the v of 0 is the first element of my permutation vector or permutation array. So it should be what? It should be less than 0, and if it is less than equal to 0 or it is greater than 1, it means what? It's the invalid condition, right? Because it's the first element of my permutation, and that element should be between what? 1 to n. So that condition I have checked here, right? And I have just pushed the nn plus 1 by 2 at the end of this vector. Just pushed nn plus 1 by 2 at the end of my vector, and just constructed the permutation vector here. And how I have constructed here, the first element of my permutation array will be what? The prefix of 0 element part, right? Because if we know how the prefix sum will work, then it's just the first element is always what? The number itself. So I've just done that I have included that in my map and stored its frequency as 1. So in the future, if the same digit has occurred again, then I can say, okay, this number has occurred, and now you're making its frequency is equal to 2. So it's not allowed, and this is not a valid permutation. Simple as that. So I have computed the nums out of the permutation, and how I computed the num is subtracting the v of I minus v of I minus 1. If we subtract the two consecutive digits in our permutation, then it will tell the digit only, right, which is present at that indexing in my original array whose prefix sum is this. So yeah, and I have again checked the nums, whether it is a valid number or not, and how I can check the validity, that it should be not less than equal to 0, it should not be greater than 1, and the count of that element should be equal to 0. And if any of this condition is obeyed, then it means what? That it's the invalid one. And if it is invalid one, just I have to mark the flag as 0 that I have printed for this part and break the loop. And if it is not, then I am using a map to store the frequency of that number and is equal to 1. And when I successfully come out of this loop, then I will check whether I have already printed the response. If I have not printed the response, then I have checked whether I have successfully constructed that permutation array or vector. If I haven't, then I just have to print no, and if I have successfully constructed, then I will just print n. So this was for if element is missing from the end of the array. Now if the first digit is deleted, right, if the first element of my permutation vector is being deleted, so what will happen if first digit is deleted? Then total we have the n minus 2 digits out of n, right? So that's the thing here, is like I have just calculated all the possible numbers in similar manner. I have checked the validity of my nums, whether my num is valid digit or not of that permutation, and if it is valid, then I have just simply pushed that into my temp vector, I've just created a temp vector which is just storing the valid permutation, right? The valid permutation one. Sorry, correction. That this temp is storing that if somewhere my condition is not obeyed, like the difference is greater than n, or difference is less than n, or difference is greater than or less than n, or the number is already being occurred, right? If that is the condition, if somewhere the number is not valid, then I will store that part into the temp vector. And why I am storing it into a temp vector? Because just we have seen in the, I guess, just I have mentioned that if we have deleted the element from the middle one, let's say C is deleted, then the difference of these two one will be surely greater than n, and we have to store the difference. Why we have to store the difference? Because if we add the b, if we add the remaining sum of remaining digits in b, then it will give that difference, that b minus d, b minus b. For that purpose only I am just storing that into my vector, and so that's the thing. So I'm just storing that into my temp vector, and I'm checking if my size of temp is equal to 0 or not. If my size of temp is 0, it means what? It means what? That I have constructed the n minus 2 elements, right? And if I have constructed the n minus 2 elements, for sure it means the first element is being deleted, right? So if first element is being deleted, then here the sum vector is what storing? N plus 1 by 2, the sum of all the digits, and I am subtracting the sum of all the valid digits which has been occurred in my permutation, right? So the missing numbers are the sum of missing numbers will be only present in the sum. So I am just telling that if the first number is missing, then I know that the sum of the missing number should be equal to the first element of my permutation. And if this is the condition, then I will just simply print yes. If the size of temp is equal to 1, it means what? Somewhere from the middle a permutation is being deleted, because I am just storing if the difference between two elements is not, if we subtract the two elements and if it's not a valid number, it means what? The permutation from between these two numbers is missing, right? And if the size of that number is equal to 1, it means what? My mp dot size, basically all the valid digits out of that permutation. How many valid digits we have till now encountered? N minus 3, right? And now this is the condition that the middle one is missing. So if the middle one is missing, it means what? The first digit is the part of my first digit of my permutation vector. Let's say the 1 here. So 1 is also the part of my nums vector, because the sum of first digit in my permutation array is what? The number itself, right? So that thing I have just did here, that I have checked whether this 1 is being occurred somewhere in between these two digits or not. If it is being occurred, it means what? It means we cannot use this digit, right? So we just have to simply print no. So if it is occurred, or v of 0 is not a valid one, basically greater than 0, greater than or less than 0, then we will just simply print yes. We will simply print no, sorry. And if these conditions are not obeyed, it means we have to check if the sum of all the digits which are not been occurred, and if we subtract that v of 0 from that, v of 0 basically that the digit, the one is also the part of my permutation is now, right? And if it is equal to the missing number, right, the missing number, the sum of missing number, then we say yes, my condition is valid. And if none of the condition is valid, then we just simply print no. So this was the entire solution, and I know it might look a bit lengthy, but if we do the dry run, then the things will be much more clear, right? So let's just do the dry run for the one of the cases and just write it. Yeah. So let's just do the dry run for this case only. So it's 1, 6, 8, and 15, right? So we see here is like 15 is present, so and the sum of this 5 numbers is equal to what? 15 only. So last digit is surely not missing. So if the last digit is surely not missing, then we will do what? We will do just subtraction here, that it's what? Equal to 5, and then we will subtract these two parts. It gives us 2, and we do subtraction of these two parts, then it's giving us what? 7, right? Let me check here. 10 and 5, 6, 7, just, and 7 is greater than 5, so we know that it is not a valid nums, and we will store that into our temp vector. I've just shown in the code, right, that here, that if the number is not a valid one, right, this number is greater than n, so it's not a valid one. So if it's not a valid one, we will store it into our temp vector, and temp vector is storing what? The difference between the two consecutive prefix sum, and the number which comes out is not a valid one. So here it's come out to be 7, and it's not a valid one. Cool. So if my temp is equal to 1, it means that here we have got the 2 digit out of what? Out of 3 digits. So here is what? Here is what? The size of temp is equal to 1 and MP of size is equal to n minus 3. So basically 5 minus 3 is equal to what? 2. So it's 2, right? So if it is 2, so it means what? The 1 is also the part of my permutation. So we have got how many digits indirectly? We have got 3 digits, 1, 3 and 5, right? And we have to just subtract what? We have to just subtract 15 minus what? The sum of all these digits, and sum of all these digits is equal to what? 5, 6, 7, 1, 8 is equal to what? 7, right? And this is matching with my condition. Like if the sum minus 0 is equal to the temp of 0, and temp of 0 is containing what? That 7 only, right? If it is matching, then we just have to print yes. And here, and just I have shown that we are we are calculating the sum of all the permutation or all the valid digits, right? So here we have just done that part just by taking here the sum vector only, variable sum, where the sum storing the sum of all the digits, and we are, as we are moving forward and getting the valid number, we are just automatically subtracting that part from the sum only. So that's the case for if the number is missing from the end somewhere, and if the number is missing from starting, just like here the 6, 8, 12 and 15, right? So here what will happen? The 15 is present, so just we will subtract these two one. It will, we'll just subtract these two part, and it will give us what? 2. It will give us if we subtract 8 from 12, then it will give us 4, and this will give us what? 3. So we have got the 3 digits. Indirectly we have got n minus, out of n we have got 2 digits, so basically n minus 2 digit we have got. So our temp vector will be what? Our temp vector will be empty. Our temp vector will be what? Empty one. So if a size of temp vector is equal to 0, then we know that the first digit of our permutation is being missing. So we will just do what? We will just add all these digits, which is equal to what? 4, 5, basically we can subtract the sum from 15 only. Yeah. So it's what? 15 minus 2 minus 4 minus 3. So it is 15 minus 12 only, no? Yeah, 15 minus 12, so it will be 3 only. Let me check here. So 9 minus the sum of these two this will be what? 5, 5, 4, 9. 9 minus 15 is equal to 6, right? So what are the number missing here? As we can see clearly, the number is missing is 5 and 1. So here whatever the number is missing, 5 and 1, okay, so 6. So we'll check whether this number, basically the sum of remaining digits, so sum of remaining digits is equal to 6, whether it is equal to the first digit of the provided permutation vector, right? Like 6 here, so it's equal to 6, so it's a valid one. And what the 6 is representing? The 6 is representing the sum of 1 and 5, and as we can clearly see here that 1 and 5 are not present. So yeah, so it's a valid one. Similarly, you can do the try run for all the cases, and just you have to keep in mind that there is only 3 possibility of deleting the number. Either we can delete it from the starting, we have to delete it from the middle, or we have to delete it from the end. And we have to keep in mind that it's a permutation, so the frequency of each digit should occur only once. It means that if he has once used that number, and again let's say the 4 will come here, then it's not a valid one. It's not a valid one, and our answer will not happen. So we have to keep in mind that, and while calculating the digit, we have to also keep in mind that it's a permutation from 1 to n. So each digit should between 1 and n, and that digit should not occur more than once. So these are some of the edge cases and the approach. And if you do the try run, if you still have any doubt, then you can try run in this test cases. Rest I think all the things are clear. And if you want to know the complexity of the code, then the complexity will be simply O of n, right? And yeah, the complexity of code will be O of n into t, and it's clearly given that the n into t is less than 2 into 10 to the power 5. So it will be clearly passed in this, and actually you can see that I have just submitted that code and just got accepted. So yeah, so this was whole approach of this question. I hope you got the crux of this problem, and if you have still any doubt, then feel free to mention in the comment section. See you in another video.